record on this computer. Okay, we're going to jump into things here and talk about fractions tonight. So I hope you guys are ready for a lot of information about fractions that'll kind of happen kind of fast here. Okay, so that's a little bit bigger. And so I'm going to give you a minute to copy down what you see on the screen. Don't make it perfect, but um, this is like an introduction to fractions, and don't feel like your little circles and your diagrams have to be perfect. In fact, if you just had about 3 of these, maybe the 3 of the circles, that would be enough to get the general concept, okay? Because I don't want you to panic and feel like, I got to draw all this real fast. So, yeah, fractions. A fraction means a part of a whole. You know, as you're writing this down, it's a part. One way I illustrated it is if I had a coffee cup, or let's just hold up my water mug here. Let's say this was made out of clay or something, and I accidentally dropped it, and it broke off into 4 pieces, say for instance, and there were 4 pieces. It's now fractured. The whole cup, okay, which is the whole, in a sense, will be the denominator. In a moment, we'll notice, is now into 4 pieces. And so if I held up one of those pieces of my broken cup here, it's a fraction of the whole. In fact, if there were 4 equal pieces that have broken off of my mug here, if they were in 4 equal size pieces and I held up one of those, I have 1/4 of the whole that goes into the whole, okay? Another way of looking at and thinking about fractions is that fractions are, like it says, it's a part of a whole. So if you have a cup, a measuring cup, if I'm holding up this measuring cup to you, and it's one whole cup, okay, that's a whole. If I have right next to it another cup, and it's the half cup measuring cup, okay, it's a half. The reason they call it a half, it's a fraction, because it's really a half of a whole cup. Okay, in where I live, we have in the kitchen measuring cups that are 1/4 of a cup and 1/8 of a cup. And what they're really saying is that's a piece of the whole cup. And that's what a fraction is. It's a part of the whole. And so we can also talk about money, and we probably will in some of the story problems. If I talk to you about out of a dollar, if I have a quarter, the reason why it's called a quarter is because it's a quarter of a dollar, 1/4 of a dollar. That's where the name came from. It's 1/4 of a dollar. You put 4 of them together, you got a whole dollar. Okay. So in a sense, that's kind of those are like 2 or 3 ways of looking at what a fraction is. And so that brings us to, let's call this pizza, since it's around dinner time here that I'm giving this talk here. I've got some pizzas drawn here on the board that I got from Papa Murphy's or somewhere, okay? And in this pizza here, this first one here, I'll call it pizza number 1 here. If I look at it and I ask you the question, what part of the whole is shaded in? Okay. So the first thing we want to do is look at the whole. Okay, like my whole cup was in 4 pieces. This pizza is in 4 pieces. So I'm gonna, out of 4 pieces, okay, 1 is shaded in. So that is literally visually, that's what the fraction 1/4, 1 out of 4 looks like. Okay. I bet you on your own notes, I could pause for a moment and see if you could on your own write the fraction, and I'll give you a hint. Count how many total parts there are. Total, that's your bottom number. That's where I put the 4. See if you could write the equivalent fraction that the picture is showing or illustrating. Okay, so I'm going to pause, give you a moment, see if you can write those. Maybe you can hear my dog in the background barking. Oh, okay. I think she's trying to tell me that the one on the second one there, okay. Now, if I write the second one here as a fraction here, I'm going to look at how many total pieces it's divided into. That pizza is divided into 4 pieces again. And how many of them are shaded in? 2. So this is a picture of 2/4. Okay. I also want you to look over here at the next one here. We'll call this example number 3 here. Okay. How many pieces are there? Okay, there's only 2, so that's my denominator. And obviously 1 is shaded in. And I want you to notice something kind of interesting here. It's part of why I had these two side by side. If you look at them visually, kind of squint your eyes a little bit, you know, so you can't see much except for the color, you'll notice if you actually squint your eyes that they're equal. It's the same amount of the whole that's actually colored, okay, colored in. And that is actually true in mathematic terms as well. 1/2 is equal to 2/4. It's the same fraction because 2/4 is actually, if I look at 2/4 here, it's actually half the whole pizza. Okay. And over here, number 3 is a half. Okay. The next one, again, we've got 4 pieces. So I'm going to write 4 as my denominator, which we'll show you what that means in a minute. 3 of them are shaded in. So your fraction should have looked like this. The next diagram, I see 6 different pieces. So that whole thing is divided into 6 pieces. 2 of them are shaded in. Okay. And then the next diagram, 1, 2, 3, 4, 5, 6. So there must be 12. That must be my denominator. And 3 of them are shaded in. Okay. So visually, that's what a fraction is, and that's what these fractions represent. Okay. As examples. All right, I'm going to move on to the next concept here, which is just to define a couple of the words that I've been giving you here for the last couple of minutes. All right. So in your notes, you might want to write, just like I did, I have a fraction called 2/3. Okay. Notice how I said thirds. Okay. Like 1/2, I say half, 2/3. Okay. The number on top is called the numerator. And that's how to spell it. Even though the writing looks kind of crazy there. I was just writing with this pen on this board here. And then the one on bottom is called the denominator. Okay. Numerators are the numbers on top, and denominators are always the number that's on the bottom. All right. Now, I'm going to give you a way to remember them, because if I ask you tomorrow, if this is new to you and I ask, which one's the numerator and which one's the denominator, those words might get jumbled in your brain and you go, I forget which is which. Here's my little visual way of remembering. In the word denominator, it's got the name Dino here. Okay, right here, I've got it here in the box here, Dino. Let's imagine that Dino's a guy who likes to wrestle, but Dino's not very good at wrestling. He always ends up on the bottom. Okay, so he's always pinned, as it were, and you can see that I'm a famous artist here by my diagram here. He's always pinned on the bottom. Okay, he's always that's where Dino always ends up. Okay, so the denominator is the number that's always on the bottom. So if you're trying to remember numerator, denominator, wait a minute, Dino, denominator, that's the guy that's the bottom number. Okay, that's just a little visual way that experts in memory use techniques like this to remember words. Okay, moving on. I'm going to give you a minute just to copy this down because I want you to take your time. I don't want you to panic. So let me just give you that minute. Okay, let's take a look here. So when we start talking about fractions, typically there are 3 types of fractions, and just to illustrate from the definitions or the examples I have here, the proper fraction. Okay, a proper fraction, if you think about the fact that a fraction is a part of a whole, like half of a pizza, or 2/3 of a pizza, is one where the number on top, the numerator, is greater than this number on bottom, okay? Then if that is the case, like 2/3 or 5/7 or any number of fractions where the number on top is smaller than the number on the bottom, the denominator, then that's what's called a proper fraction. And the reason why it's proper, if this helps you remember, is proper because it's properly a part of it's a fraction that's part of a whole, and fractions are supposed to be parts of a whole, okay? And so that's one way to think about it. So it's proper because the number on top is smaller. All right. Improper means that the number on the top, the numerator, is greater than the number on the bottom. So in my three examples, I got 3/2, 7/5, and I got a trick one over here, 5/5. But most of the time, you're going to be looking at a fraction where the number on top is greater. If that's the case, and I'll start using this language as we start talking about fractions, if we see this number on top as being bigger, we know that's an improper fraction, okay? Now, occasionally you will run into a fraction like 5/5, or you might have, 9/9 or whatever. Occasionally you're going to run into a fraction like that. And they, by definition, if you try to figure out, well, do I call that a proper or improper? They've defined it as an improper fraction, probably logically because it's not really a part of the whole. It is the whole. 5/5 pieces is the whole pizza in a sense. So it falls under the definition of being an improper fraction, just so you'll know that. And then the last type of fraction for this particular slide is what's called a mixed fraction. And it actually means what it says. I'm mixing a whole number here, 2, that's a whole number, okay? It's not a fraction, with a fraction. So I got 2 1/3, okay? Most of us are, you might be 5'5" and 1/4 inch, okay? Many measurements in life, you'll have the whole number, the 5 feet, and then, and then 5 1/2 inches, you have that part of it. So that's what a mixed fraction is. You got a whole number mixed with a fraction. And so we're mixing them. And so we call that a mixed fraction by definition. Okay. So if I kind of, a couple more types of fractions that I wanted to point out to you. Take a moment and go ahead and copy this as well. Okay, I hope I've given you a moment or two to copy these down. Talking about types of fractions here, and what I have on the screen here in front of you is the first one. If I kind of choose a color here to kind of distinguish them from the other ones, okay, this first type of fraction here, number 1 here, okay, is what we call equivalent fractions, okay? And equivalent has the word, if you wanted to add this to your notes here, equal, it sounds like it's saying equal, okay? These are fractions that are equal, and we already talked about the fact that 1/2 of a pizza is the same thing as 2/4 of the pizza, okay? It's an equivalent fraction. And if I go back a slide, so I'll be back to this in a moment, but here, go back 2 slides. We talked about the fact that over here, this number 2 and 3 here, a half is the one on the very far right here is a half a pizza, number 3 here, and 2/4, you can see that it's the same amount of the pizza if you look at just the color, okay? They are equivalent fractions. Even though the numbers are different, they actually are equivalent or equal, all right? And by the way, I could also divide a pizza up into a whole bunch of pieces, let's say I divided it into like 8 pieces here, okay? And if I shaded this, so this is now 8 pieces of the pizza. And if I started shading this in, you see how I shaded in basically half the pizza, okay? But there's 8 pieces. So this is really, as a fraction, it's 4, the top 4 out of 8 shaded in, but it is still 1/2. It's a half the pizza. So basically, here's a little clue here. anytime the number on top, the numerator is half the denominator, that means it equals a half. If I have 20 over 40, that's a half. I've divided that pizza up into 40 pieces, really tiny pieces. And so that means a half of something, okay? All right, now the next example, we'll call this example number 2 here, is also equivalent, and I'm gonna show you why, okay? If even though they look, well, that looks totally different, teacher. How do you know these two fractions, 8/12 and 2/3, are equal? Okay, I'm going to tell you 2 ways. There's actually a couple ways to know. One way is if I reduced this down, and reducing means you ask, is there something that goes into 8 and 12? And so I took the biggest number that I know goes into both 8 and 12. I know 4 goes into 12. I'm sorry, 4 goes into 8 2 times. So that, and 4 goes into 12 3 times. So if I reduce that down, I can see that these are equal. They're the same. Okay, that's one way to know if two fractions are equal, is to reduce them down to their lowest terms. Another way, this is actually faster and simpler, is just to multiply it crossed like this. Okay, so if I draw like an arrow here, multiplying across. If I multiply across and I get the same answer both times, then those two fractions are equal. 12 times 2 is 24, and 8 times 3 is 24. So these are equivalent fractions. They're actually equal, okay? And so if I shaded in my circle again, in my pizza again, I drew my pizza and shaded this in, 2/3 is like, it's something kind of like this, okay? Shaded in, that's 2/3 of the pizza. And I could have, yeah, if that was 3 pieces, I could have shaded in all this much of the pizza, that's 2/3. But if I divided it into 12 pieces, it would still reduce down to the same amount of the pizza, okay? All right, so that's equivalent fractions. Then you have something over here on the right called like fractions, okay? And they're like, I'm gonna give you a little clue on how to remember they're like, okay? They're like if the Dino, the guy on the bottom that always gets pinned, is the same number, okay? So 2/3 and 1/3 are what they call like fractions, okay? They're like because they share the same denominator. Likewise, 5/7 and 11/7 are like fractions because they have a like denominator, okay? And then of course, unlike probably logically would mean fractions that have different denominators are considered unlike, okay, from each other. Now, it's possible, therefore, to have unlike denominators and have them be unlike fractions, but also be equivalent. So for instance, look at number 2 here. These are unlike fractions. They have different denominators, but they're actually also equivalent though. So those are some terms. Those are some types of fractions. And we'll spend most of our time just talking about the first 3: proper, improper, and mixed. But you'll have a little bit of work this week related to all of them, okay? So please don't feel like you have to copy down this slide here, okay? And I will send you this in email. What I want to do is just spend a moment and have you look with me together, and let's kind of figure out some answers here, okay? Let's look at this. What type of fraction is this, okay? I'll ask you number 1 here. Think about it. Is it proper, improper, or mixed? Hopefully you can look at that and go, oh yeah, that's what my teacher said is a proper fraction, okay? Because it's got a smaller denominator on top, okay? Look at the next one, 5/7. What type? Proper, improper, or mixed? I'm sorry about this thing here, but that's again proper, okay? You probably think, oh, he was trying to trick me, okay? But that's a proper fraction, okay? The next one, oh, you probably remembered, that's mixing a whole with a fraction. This is a mixed fraction, okay? So it's just one fraction all by itself. And then you hopefully number 4, you remembered if it's the same numerator and denominator, they call that improper, okay? And if I had one, if I add just one more to my slide here, if I had one that was 5/3, you would say that that's improper as well, okay? Because the numerator is greater. All right, now we have pairs of fractions. And so we're going to ask that question again. Are these equivalent? Are they like, or are they unlike? Okay. So let's just look at number 5 here, 3/4 and 4/5. And if they ask, well, first of all, I see this denominator right here. Oh, I could say that these are like fractions, okay? Now, out of curiosity, 3 times 5 is 15 and 4 times 5 is 20. They're not equivalent fractions. They're not equal, okay? But they are like because they share the same deno. All right. 2/4 and 8/16. All right. Well, by definition, I mentioned to you guys about 5 minutes ago, if the number on top is half the number on bottom, then it's half, okay? So these are both equivalent, okay? They're equivalent fractions because, well, if I multiply 4 times 8, I get 32, and 2 times 16, I get 32. They're equal to each other, okay? Then I've got 8/9 and 2/5. Oh, 8 times 5 is 40. 2 times 9 is 18. They're not equivalent. They're not like. They don't have the same deno. These must be, by definition, then, unlike fractions. Okay, so that's just a little review here before I move on to the next concept. All right, moving on. Converting mixed to improper fractions. So I'm going to give you guys a moment to just copy down all of these fractions because I don't want you to feel rushed while I'm talking. Okay, let's spend a few moments converting mixed to improper. So what this actually means is I've got 6 different mixed fractions on the screen in front of you, okay? And many times when you're working with fractions, you're going to need to change them to improper before you can multiply or divide them, okay? So here's how you do it. And we're going to do a number of them together until you finally get the hang of it. I've got 3 1/3. To change that mixed into an improper, you multiply the denominator times the whole number and then add the numerator to the answer. So 3 times 3 is 9, plus 1 is 10 over 3. So what I did is I just brought my 3 over. Okay, that's the denominator there stays the same. Okay, let's do another one. I've got a mixed fraction called 5 7/8. I'm going to convert it to improper. I'm going to multiply the bottom number times the whole number. 8 times 5 is 40, plus the numerator is 47 over the denominator stays the same. Okay, I have converted mixed to improper. Improper because this is bigger than this. Okay, number 3, 5 times 4 is 20, plus 3 is 23 over 5. Okay, all right, I'm going to give you guys about 20 seconds to do the next 3 on your own. Okay, I'm going to pick things up again here. To convert the mixed fraction of 8 2/3 to an improper, I multiply 3 times 8 and I get 24, plus 2 is 26 over 3. Okay. 1 1/2. 1 times 2 is 2, plus 1 is 3 over 2. And 7 3/4, if I multiply the denominator times the whole number, 28, 29, 30, 31 over 4. Okay, so we just successfully converted mixed fractions into improper. And again, they're called improper because this number on the top is greater now than the number on the bottom. The numerator is greater than the denominator. All right, now I'll pause again and let you copy these down so we can take our time. All right, so we are converting improper. These are improper fractions because the number on top, the numerator is greater, to mixed. Here's how we do it. We divide the denominator into the numerator. We ask this question: how many times does 3 divide into 5? And we write the answer down. It goes 1 time. How many are left over? Okay, well, 3, 4, 5. There's 2 left over. And then we keep, again, just like when we go the other way, we keep the same denominator. Okay, so that's one thing that stays the same, is the denominator stays the same when we're converting either way. Okay, let's look at number 2 again. How many times is 5 divided into 7? It goes into it 1 time. How many are left over? 2. In both examples, it's 2. And we keep the denominator the same. Okay, in example number 3 here, how many times we've got an improper fraction? They ask us to change it to mixed. Divide the numerator into the denominator. It goes 2 times. Now listen carefully how I say this, because 2 times 7 is 14. What's the difference between that answer, 14, and 15? 1. And then again, keep your denominator the same. Okay, let's talk our way through 3 more. 21 over 8. How many times does 8 go into 21? It only goes, and again, this is because I know my times tables, which you need to learn. If you haven't learned them already, get a free app for your phone and start learning them, okay? 8 goes into 21. Well, 8 times 3 is 24, so that's too much. So it only goes into it 2 times. Now listen to this important thinking right here. 8 times 2 is 16, okay? What's the difference between 16 and 21? They're 5 away from each other, okay? So if I count up from 16 to 20, it's 4 plus 1 is 5. So that's how many are left over. And again, we keep our denominator the same, okay? All right, I'm going to give you about 10 seconds to do number 5 and 6. Okay, that's about 10 seconds. All right, so I'm converting, this is a improper fraction because the numerator is greater than the denominator. If I'm supposed to convert it to mixed, I ask myself, how many times will 7 go into 31? Well, I know my times tables. I know that 7 times 4 is 28. So it goes into it 4 times. Now I'm thinking about 7 times 4 is 28. Thinking about that 28 there. I'm just going to write it real small here so it doesn't confuse you. What's the difference between 28? If I subtracted 28 from 31, or how far away are they from each other? They're 3 away from each other, okay? So that becomes my numerator, and my denominator stays the same, 7s, okay? 15 goes into 45. This is a bit of a trick one because it actually goes into it, especially since it's bigger numbers, 3 times. Because 15 times 2 is 30, and another 15 is 45. So you'll notice this is not a fraction. That's just the answer, okay? 45 over 15 is 3. It's the same thing as 3. And so that would be the answer. You don't have to put a fraction there, okay? All right, we're going to move on to how to tell if fractions are equivalent. And I'm not going to spend much time on this because I've already hit on this, okay? So I'm just going to remind you that we kind of talked about 2 methods already, okay? Method 1 is to reduce them down to their lowest terms. So I wouldn't, you could just watch this, but I've got example number 1 here, okay, of these fractions here. If I look at 8/12 and I reduced it, let's pick the biggest number that goes into both these 2 numbers. 4 goes into 8 2 times, and 4 goes into 12 3 times, okay? All right, what's the biggest number that goes into these 2 numbers? 8 goes into both of these. 8 goes into 16 2 times, 8 goes into 24 3 times. Oh, yeah, they're equivalent, okay? So that's method number one. Now, method number two, which I already mentioned, is I could have cross multiplied, but you see that's going to end up with some big numbers, but I could have worked it out by hand and gone 8 times 24 and gotten a big number, 16 times 12 and gotten a big number and looked, oh, they're the same. And they would be in this case, okay? Again, 3/4 and 9/12, okay? 3/4 doesn't reduce down anymore, but 9/12 does. If I ask myself, how many times does 3 go into 9? It goes into it 3. How many times does 3 go into 12? 4. Yeah, these are equivalent fractions. I could have also multiplied across and gotten 36 each time, okay? Those are two ways to find out if something's equivalent. All right. Now I want to talk about some signs. So I'm going to give you a moment to kind of copy down these signs here, and we'll talk about what they mean. Okay, easiest way for me to kind of explain these is just to start off by looking at it. This is the equal sign, and it's actually a pretty powerful symbol when you start doing math, and especially in algebra, because it means that something on the left is equal to something on the right, and so we use that a lot in mathematics. Okay, but it means that two things are the same; they have the same value in a sense. Um, so for instance, we've talked about 1/2 is equal to 2 out of 4. Why? Because the numerators are half the denominators, okay? Which is also the same as 3/6, which is also equal to 4/8, etc. Okay? So that equal sign means equal. Now, then you've also got this thing here, like here, this symbol here, okay? Greater than, um, it can mean greater than or it can mean less than, but it depends on what number it's facing. So for instance, look at this example here. If I call this example 1 was my greater than or less than, if this example here is example number 2 here, 3/4 of a pizza is more than half the pizza, 3 out of 4 pieces. It is greater than, notice I've got like this, it's greater than 1/4, okay? And so here's how you remember, how do I know which side of this symbol is pointing to the greater number? That's where we get into my possibly award-winning drawing of an alligator here, okay, where I probably will win prize money for my artistic skills. This is an alligator. Okay, that was a joke. This is an alligator that's got its mouth open, okay? It's got its big jaws open. Okay, this is the jaw of the alligator, okay? All right. The open mouth of the alligator is going to eat something big, okay? The open end of the alligator here faces the big number, okay? The bigger number. So in this case, 3/4, you'll see the open jaw of the alligator is facing the bigger number, all right? But notice in the example below here, it's facing the opposite direction. Why? Because 2 out of 5 pieces is less than a half the pizza. 3 out of 5 pizzas is more than half the pizza, okay? So the open jaw of the alligator is always facing the greater number, okay? So if I gave you like the fractions like this, 2/3 and 2/7, and I ask you, which way should the alligator go? You should be able to look at that and go, okay, 2/3 is more than half the pizza. 2/7, that's less than half. So my less than is going to face this way. My greater than is going to face like this, okay, towards the bigger number. So that's what these symbols, okay, these are just some signs, okay, that we use when we talk about mass: equal, greater than, less than. All right. Let's just talk about some sizes of fractions, okay, or just kind of comparing some fractions to figure out what's, which way are we going to go, greater than or less than, okay? If we look at these fractions here, and I got my first example, number 1, 1/2 is greater than 3/8. If they ask you to compare, tell me which is greater. Let me give you a moment to copy down these numbers. I don't want to rush you, so I'm going to pause my recording again. All right, let's talk about these fractions. I'm going to tell you a little clue, okay? I'm going to write the word clue here, okay? This is a little secret, okay? I'm just going to say, look at the denominator, okay? Okay, that's the clue, is to look at the denominator and ask, what number, and I would go ahead and write this on your notes, is half of that deno. Okay, deno stands for denominator. All right, that is our clue. It's our magic clue, is to look at the denominator and ask yourself, what number is half of that deno? Okay, and let me give you a moment to finish copying that down, and then we're going to take a look here. All right, let's look at number 2 here. Okay, I've got 4 6 and 7 8. All right, 4 is if I think about what's half of 6, right? What is half of 6? Half of 6, again, we're focusing on the denominator here. Half of 6 is 3. I've got 4. It's a little bit more than half. This fraction is, if it was a pizza, it's a little bit more than half the pizza. Okay. Look at the next fraction, 7 eighths. Again, look at the denominator. Ask yourself, what's half of deno? 4. I've got 5, 6, 7. I've got quite a bit more than half here in this one. So just by thinking about it that way, I would draw my alligator like this. 7 eighths really is almost all the pizza, right? Is more than 4 sixths. And again, my clue is to look at the denominator. Look at the next example, number 3 here. I'm asking which is greater, 3/7 or 1/3. I'm going to look at 7 here and ask myself, what's half of 7? 3.5. So I have a little bit less than a half. Okay. What in my next fraction, what's half of 3? I've got 1.5. Okay. This is only 1/3. This is 3/7. This is a little bit greater than a third. Okay. Because this is almost a half of it. Okay. But, it's just slightly more. If you think about it as a pizza, 1/3 of the pieces, 1/3 of them versus 3 out of 7, it's a little bit more. Okay. 2/4. Again, asking what's half of 4? 2. This is half. This is the same half of the pizza. This is 1/3. What is, again, I'm looking at deno. What's half of 3? 1.5. 1.5 is half of 3. I have 1. I have less than a half. So this is the way my symbol is going to go, because this is less than a half. Okay. So that is my magic clue when I'm teaching students to try to compare the size of fractions next to each other. Look at that denominator always and ask yourself, what's half of that? And it'll start giving you a better visual picture, mental picture. Okay. All right, let's talk about reducing fractions to their lowest terms, a key concept in this class. So go ahead and copy this down. Okay, I hope I gave you enough time there to copy all this down. Let's talk about reducing. So reducing, the way we reduce things is, if I gave you kind of a simpler example, 2 out of 4, that's a nice simple example, okay? To reduce it, this is what it means to reduce. You ask yourself, is there something that multiplies cleanly into 2 and 4, the top and the bottom number? If I divide it by the same number, and in this case, yeah, 2 goes into both of these, okay? 2 goes into 4 one time, and 2 goes into itself one time, and 2 goes into 4 twice. And then 1/2 doesn't reduce anymore, okay? So let's walk over here to number 1 here. And I'm asking myself, 6/8, is there a number that multiplies cleanly into both the numerator and the denominator? Is there a number that divides into both? Okay. And I know that 2 goes into both. I know 3 goes into 6, but 3 doesn't go into 8 cleanly. So 2 is the number. It's the biggest number that goes into both. 2 goes into 6 3 times. 2 goes into 8. So I'm going to write down divided by 2 here just to visually show that, okay? Divide by 2, okay? 2 goes into 8 4 times, okay? So 6/8 is equivalent to 3/4, but I reduced it down. And 3/4 does not reduce down anymore. We already did this second one here to 1/2. Okay, I forgot that it was on the screen. The next example, number 3 here, ask yourself, what's the biggest number I can use? Pick the biggest number you can find that divides cleanly into 8 and 12. Okay, if you're thinking 4, yep, that's the biggest one. 4 goes into both. 4 goes into 8 twice. 4 goes into 12 3 times. Okay. Again, number 4 here, what is the biggest number? Because I know my times tables, I'm looking at 14 and 21 and 7 is just popping out in my brain. And it will in yours too when you start learning your times tables, okay, if you have them. 7 goes into 14 twice, and it goes into 21 3 times, okay? That must mean that 8 twelfths is equal to 14 21s because they both reduce down to 2/3, okay? I see 27 over 36, and the first thing I think of is 9. 9 goes into 27 3 times, and then into 36 4 times, okay? Now, here's a mixed fraction. Can you reduce mixed? Yeah, you're going to be doing that a lot, okay? Here's how you reduce. You write equals, and I'm going to keep 3 the same, and then I'm going to look at this fraction, 5/15. Is there a number that goes into both? Yeah, 5 goes into 15 once. 5 goes into, I'm sorry, 5 goes into 5 once. 5 goes into 15 3 times. So it reduces down to 3 1/3, okay? I have also on the screen a little note that says, see intro. This is your homework PDF here. And there is a page that looks kind of like this in your homework where you can solve some. And I think I asked you to do like this, just the first row of them. But I wanted to kind of illustrate this to kind of give you the idea of what this looks like. So for instance, it's got this little box here, okay? This little box here, and it says identify the fraction and reduce to lowest terms. All right, 10, it says time, 1 minute is 60 seconds, okay? That's my whole, that's my bottom number. 10 seconds is what fraction of a minute, okay? It's 10 over 60. And it reduces down, 10 goes into itself once, 10 goes into 66 times. So it reduces down to lowest terms to 1/6. 15 seconds out of 60 would be 15 over 60. And that reduces down because 15 goes into itself once and into 64 times. Or you could divide 5 into both and then reduce it down even some more after that, okay? 30 seconds out of 60 is 30 over 60, which is 1/2, okay? So that's how you do that. The next one, let's go down here, length of a football field. One football field is 100 yards. That's going to be my denominator, okay? 5 yards is what fraction of it would be 5 over 100. Does that reduce down? Yeah, because 5 goes into itself once, 5 goes into 100 20 times, okay? 20 yards out of 100 is 20 over 100, reduces down to 1/5. Okay, so anyway, that's how you'll do that homework page, just so you'll know when you see that in your homework, okay? All right, let's move on to my next slide here. I'm going to talk about these terms, so go ahead and take a moment and copy them down in your notes. Okay, let me talk about these definitions here. The first one, the first term is something called a prime number, okay? And prime numbers, okay, these things called prime numbers, they are numbers that can only be divided by themselves, okay, and 1. So the only thing that goes into 2 is 2, and 1, of course. So 1 times 2 is 2. Only thing that goes into 3 is 3. Only thing that goes into 11 is 11. Nothing else divides into it, multiplies into it. Nothing else goes into 17 or 23. So these are all, by definition, what's called prime numbers, okay? You actually have in your homework chart, you have a page somewhere in there where you've got all kinds of prime numbers that you'll be able to look at. But just so you know, I've given you a whole bunch of them, but not that you need to learn them all, but but those are prime numbers. All right. Composite, composed of, okay? The word composite means like composed of more than one thing, okay? They can be divided evenly by more than one and themselves, okay? So 4 is a composite number by definition because it's composed of 4 times 1. Those are factors of it. They multiply into it, but also 2 times 2, 2 goes into it as well. So it's composite. 6 has factors of 1, 6, 2, and 3. Those are all factors of, they multiply into 6. All of these numbers are examples of composite numbers. They're things that things can be multiplied into, okay? We won't spend a lot of time on that, but I'm just kind of defining terms. And I also do want to show you, don't feel like you have to copy all of these, just do a couple of them maybe. Something called an exponent, okay? And exponents and factors. I've already been talking about factors a little bit, but exponents, if you ever see this in math, and we won't have a lot of this in this course, but you'll start getting into this more in 70 and then in 76 math. When you see the little number on top here, this is called the exponent, okay? So if I kind of draw an arrow to it, just by definition, that is the exponent, okay? And what it means is the root of it, the 2 down here, the big 2, is multiplied by itself twice, 2 times 2, because that's a 2 there. If I have 2 to the exponent 3, it means I take the root number 2 times 2 times 2. I do it 3 times, okay, which equals 2 times 2 is 4, times 2 is 8. All right. And then if I had this example here, just kind of faded here, but if I have 2 to the 4th, it would just mean 2 4 times, times 2, times 2, times 2, okay? And then 3 to the 3rd, again, would just be as an exponent, 3 times 3 times 3. All right, and again, I go 3 times 3 is 9, times 3 is 27. So I'm just gonna write that answer down. Those are exponents. So when you see that little number on top, okay, that is the exponent. All right. Factors we've already talked about on the last slide, but again, if I ask you to list all the factors of 6, I know that 1 times 6 is 6. So those are factors. I know that 2 times 3 are factors because 2 times 3 is 6. These are all the factors of 6. Okay, so if I drew like lines like this, okay, I'm showing you that they're all factors of 6. The number 12, for instance, I know that 1 and 12 are always going to be factors. 1 and the number itself will always be factors. I know that 2 times 6 is 12, and I know that 3 times 4 is 12. These are all 1, 2, 3, 4, there are 6 factors of the number 12. They all multiply into, same with 18. It's going to have 6 and 3 and 9 and 2 and 1 and 18. Okay. All right. Those are called factors. Now we're going to talk a little bit about something called the least common multiple. So I'll let you copy that down. Okay. What we mean by the LCM, or the lowest common multiple, is what is the lowest number that both numbers multiply into, okay? So if I ask you what's the lowest number that both 2 and 3 go into, okay, they both go into 6, okay? So if I put 6 down here as an answer, okay, because 3 times 2 is 6 and 2 goes into 6. They don't both go into 2, or I'm sorry, they don't both go into 3. If I ask you what's the lowest common multiple, and by the way, we will also get into something called LCD, the lowest common denominator, okay? We'll be talking about the same concept in a week here. But in this example, 4 and 5, what's the lowest number that both 4 and 5 multiply into? Okay, well, they both go into 20. Is that the lowest number? Well, let's pick the biggest of the two numbers. Do they both go into 5? No. Do they both go into 10 if I double 5? No, 4 doesn't go into 10 cleanly. Do they both go into 15 if I triple 5? No, 4 does not go cleanly into 15. Yeah, 20 is my lowest common multiple. 6 and 12. Now, here's a bit of a trick one here. What's the lowest number, think about it logically, that both 6 and 12 go into? The lowest number. Well, ladies and gentlemen, the lowest number they both go into is 12, because 12 goes into itself once, and 6 also goes into 12. That's the lowest number that these multiply into, okay? 3 and 4, again, speaking of the number 12, if I just looked at 4, it's the bigger of the two numbers. Does 3 go into 4? No. If I double it, 8. Does 3 go into 8? No. Triple, well, that's it, 12. 3 times 4, okay? So that's this idea of the least common multiple. It's the one that they both multiply into, okay? I'm not going to spend time on this slide because I think we've already talked about this concept, but if, as kind of review, they ask you to list all the factors of 4, you would list 4 and 1 and 2, because 2 times 2 is 4. That's all the actual numbers that multiply into 4. If I ask you for the factors of 7, you would just list 7 and 1, okay? Because it's a prime number. If I ask you for the factors of 10, 10, 1, 2, and 5, okay? Those are the factors. And that's it. We're all finished. All right, a lot of concepts, and I hope that I made them clear. Let's see here. Let me pause my recording.